All right, guys, are there any questions over any of the assignments so far? Thank you. Not too much.
Look at that.
Are there any questions over the homework? What we're looking at today is two more examples of solving these radical equations. And the steps that we're going to use to solve this one here are very similar to what we did yesterday and the day before, but there's going to be more steps. Not different steps, just more of them. Now, when we look at this problem here, we've got the square root of 2x is equal to the square root of x plus 7 minus 1. So we have more than one radical, and we do have them at least evenly spaced out. We've only got one on either side. So what we're going to need to do is take both sides to the second power, which for us here is nice on the left-hand side, because the square root of 2x squared, well, the square root and square will cancel out, leaving us with 2x is equal to now the right-hand side, because we do have two terms, we actually have to multiply it by itself. Now, when we do this multiplication, we're going to use our distributive property, just like if we were multiplying x minus 1 times x minus 1. So here we're going to multiply the radicals first. So square root of x plus 7 times square root of x plus 7, well, that's going to be the square root of x plus 7 squared, because it's being multiplied by itself, which realistically just means that the radical, the square root, and the square will cancel each other out. Our next one's going to be square root of x plus 7 times negative 1. So this is going to be negative square root of x plus 7. Now we can move on to the negative 1 and multiply it through. Well, negative 1 times square root of x plus 7 is negative square root x plus 7. And lastly, negative 1 times negative 1 is plus 1. Questions on this so far? Well, here we would have 2x. Now, as we said, the square root and square here will cancel out, leaving us with x plus 7. Negative square root of x plus 7 minus square root of x minus x plus 7. Well, these are both the same radical, yes? So we can subtract the numbers in front of it. So negative 1 minus 1 is negative 2 square root of any questions on how we got to this point here? Well, we can still combine like terms because our 7 and 1, which really just tells us that 2x is equal to x plus 8 minus 2 times the square root of x plus 7. Any questions on any of this here so far? Well, we still have a radical, yes? Well, the main thing when we solve these radicals is we first need to get the radical by itself, yes? We did that once already, got them evenly spaced out and squared. We're going to do it again. So now we want to get this radical, the square root of x plus 7 by itself, and do the squaring all over again. Well, the first thing we can do is subtract x from both sides. We can also subtract 8 here too if we wanted. Because if we subtract x from both sides, we get x is equal to 8 minus 2 square root of x plus 7. We can also subtract the 8, telling us that x minus 8 is equal to negative 2 square root of x plus 7. Is the radical by itself? Well, no. What do we need to do to get it by itself? Divide both sides by negative 2. And we divide both sides by negative 2. Just going to keep doing that. We'll get x minus 8 divided by negative 2 is equal to the square root of x plus 7. Well, is the radical by itself now? Yeah. Well, to simplify this radical, we need to square both sides again. Yes. Over here? We could, yes. Because what we could say instead of this here is that it is negative x plus 8. That would be perfectly fine too, because the negative 2 that we divided by, we can take that negative and move it to the numerator. But if we do that, we're going to change the x from being positive to negative and the 8 from being negative to positive. And we could do that, or we can leave the negative in the denominator. Either way works. Good question. Any other questions on this here before we start squaring? Now, luckily for us, on the right-hand side, the radical and the square will cancel, leaving us with x plus 7. Now, on the left-hand side, we're going to need to square our rational expression. So what we're saying, realistically, is that we have negative x plus 8 over 2 times negative x plus 8 over 2. X plus 7 is nice. Any questions on this here before we start multiplying? Now the denominators are kind of nice to multiply. 2 times 2 is 4. Now we multiply the numerators, we'll use our distributive property. Negative x times negative x is positive x squared. Negative x times 8, positive 8, is negative 8x. 8 times negative x is negative 8x. And 8 times 8 would be plus 64. Now if we combine like terms, we would get x squared minus 16x plus 64 divided by 4 is equal to x plus 7. Any questions on any of this here? Well, we do know that we have a quadratic, yes? So we need this thing equal to 0. So what are we going to need to do? Well, we'll need it equal to 0, yes? Now, this might not be very obvious, but that 4 in the denominator is really annoying, yes? It's kind of going to make this thing frustrating a little bit harder. What would happen if I multiply this entire side by 4? Those would cancel out, yes? But that seems like a little bit of a cheat to try to do that, yes? But this works, and the reason that this works is as long as we multiply the entire equation by 4. And what we're using is something called a scalar. We're scaling the entire equation up or down based off of whatever number we multiply everything by. We can do this with constant terms. We can't do it with variables. We can do it with a number. We can't do it with a variable. And this will change what the function looks like, the overall graph. It will change what it looks like. But the one thing it doesn't change is the x-intercepts. It doesn't change the solutions. It'll change everything else, but it won't change where it crosses the x-axis, which is what we want. We want where it crosses the x-axis. So doing this is nice because those are gone. X squared minus 16x plus 64 is equal to 4x plus 28, because we multiply the other side by 4. Well, now it's easier to get this thing equal to 0, yes? So at this point here, we can subtract 4x from both sides, and we can also subtract 28. Here, I'm doing it in one step, just because I know you guys are starting to probably run out of room, yes? Or already ran out of room. Which would give us x squared minus 20x plus 36 is equal to 0. Do we want to factor, graph, or quadratic formula? Factor. Since 36 is positive, the signs are the same and they match the sign of the middle term, which is negative and negative. Factors of x squared are x and x. And the factors of 36 that we want are 2 and 18. Because 2 times 18 would give us 36, and 2 plus 18 is 20. Well, negative 2 minus 18 would be negative 20. Now at this point here, we would set both of these equal to 0. Here we would add 2 to both sides, telling us x is equal to 2. Here we would add 18 to both sides, telling us x is equal to 18. So once we got this all the way down and solved, it's saying that x is equal to 2 or x is equal to 18. Any questions on this here? We can check this here to make sure it does work. Square root of 2 times 2 is equal to the square root of 2 plus 7 minus 1. Well, here 2 times 2 is 4. Square root of 4 is 2. Okay? 7 plus 2 is 9. So that works. 18. So we have 2 times 18 equals square root of 18 plus 7 minus 1. And most likely, if y'all are checking this here, you would have stuck the whole thing into the calculator each side. Because we could have stuck square root of 2 times 18 into the calculator, and this would have given us 6. Because 2 times 18 is 36. Square root of 36 is 6. 18 plus 7 is 25. Square root of 20. So this one here is interesting because I think this is one of the first ones that we've had where, or one of the few that we've had where a positive number didn't work. Because all the rest of them, especially yesterday, the ones that didn't work were the negative numbers, not the positive. Here we have a positive number that doesn't work. But that's it. Now, again, the reason I wanted to show you one of these here is so that y'all have seen how this works. This here, was this any more difficult than what we did yesterday? Not really. I mean, it's more involved. We have a lot more steps. But again, all the steps we did weren't any more difficult. We were doing the exact same steps. It did get a little tricky when we hit the fraction. Having to square that fraction was a little bit tricky, but not too much as long as we took it step by step, yes? And I wanted to show this here because this one here most likely is not going to, in the book, there's not one like this. There are problems similar to this, but when we got down to where the variable, after we squared it the second time, or where we're about to square get the radical by itself, all the variables actually would cancel out for the ones that they have. So it ends up being just the square root equals a number, square it, it's a little bit easier to work with. But these here are possible and they're not that bad. So you might see these at a college algebra level. They'll bring these up, but that's about it. I won't put one of these on the test. Questions on this here? I'm not going to worry about doing this one here because it's not any different than what we just did. It's just doing more steps of it because we have to repeat the process.